So hey guys, welcome to day number 13. Today gonna be very important, and trust me, why important? Because anytime in past, in present, or in future you gonna give a interview on the front end. In front end, maybe it's design, maybe it's verification. For sure you gonna get one questions, and that is, what's the difference between a blocking and a non-blocking assignment? There would be for sure. And that's why for today's video there would be little more theory, little more discussion. Please bear with me because it's very important. We need to give this answer perfectly, that they should feel that we know what is happening. We have the intuition, not only we are mugging up the theory and we are vomiting in the interview. We know what thing is happening and we digested the concept and now we are explaining things. So that's why it's very important. And before we start, I deserve to get a like in this video. So today we're gonna discuss about this one, a clocked always block. But before we discuss about what's the difference between this always block and this always block, we're gonna need to know something about the assignment in the Verilog. So what does assignment means? Assignment means this hand is equal to this hand. This means assignment. I am assigning the value of this hand to this hand. This is a simple example, layman's example. So anytime we gonna use assignment in our Verilog, we have three type of assignment. You have already used two type of assignment till date. We gonna introduce third one, and which will be called a non-blocking assignment. I'll come there, don't worry. So the first type of assignment, and that is a continuous assignment, which is which is achieved using a keyword called assign. And this keyword assign, if you write anything like a equal to b, then for sure b will become a where. For sure, if a is a registered type, any other type, you will get an error. So that's why a need to be where. It's, we all know. And this is the continuous statement, like there is no clock control, nothing, there is no control at all. Any time, any fraction of second, b gonna change, a also will be changing. You can write this one like in our general conventional coding. What happened if you write something in line number 1, right? So for example, I have written this fellow in line number 1, and we are going down to line number 10. So we feel like, hey, this never gonna execute because we are at line number 10, and mostly our general purpose coding, what they start from line 1 and they go down. But here in this type of assignment, this line can get executed anytime your right hand side gonna change. So that's are the difference between a conventional coding and Verilog. You need to be sure that you are knowing it, right? So we know about this type of assignment. This is a type number 1. Second type we have, and that is a blocking assignment. Now as name suggests, blocking means it is blocking something. So the question is, what does it blocking? But before I go little depth in this, just one thing I need to add around this, and that is, this assign statement can only be used outside a procedure block. Now what's a procedure block? We have used always, right? So always is a procedure block. There is an initial, which is a procedure block. So inside any procedure block, because that, as name suggests, procedure means I will do one by one, but this assign statement gonna execute anytime. So that's why this type of assign you need to do outside any procedure block. So that's all for type 1. Now type 2 is your blocking assignment. So the question is, what does it is blocking? What does it is blocking? See, and this blocking statement need to be inside a procedure block, always or initial. And what does it blocking? It is blocking the next line. If I write a equal to b and then I write c equal to d, then till the time a equal to b got executed, got simulated or anything, your this line gonna be paused in hold. So that means this first statement is blocking my second statement and all the following statements. So that's why it got its name as blocking statement. Don't worry, I will explain you why we need a blocking and a non-blocking assignment here. Continuous assignment we need because we're gonna simulate where those things, and to simulate those type of things in the hardware domain, we need to have this capability. So I hope you are sure about why we need type 1. But the question is that what's the need of type 2 and a extra type? Type 2 is needed because that's how conventional coding work. But what does type 3 is needed? So type 3 is your non-blocking. As n name suggests, it is like it won't block anything. So that means if I write a equal to b, I am not writing, I'll tell you what's the exact symbol, and then I write c equal to d. Equal to means I'm assigning, right? We are learning about assignment statement. Then these two will happen concurrently if we haven't defined any delay component. I'll tell you how we define delay component, and that's where it is actually emulating the hardware things. In first class only I said, right, there are many occasions where we need to do the execution parallelly, similar at the same time. So that time this non-blocking assignment actually help you, and mostly non-blocking assignment help you designing a sequential circuit. I will explain you what's the why in sequential circuit, what's the difference thing is happening in sequential circuit than a your combinational circuit, so that we need this type of non-blocking statement. But for now, hold, like, be patient. Okay, so now what's the symbol? So symbol is very non-intuitive, and that is this symbol. Let I think it is clear. Okay, let me write it here. It is this symbol, right? You may find it is an arithmetic symbol, but here your compiler, we know it's a non-blocking statement. So before I go to more depth, why blocking, why non-blocking, we need to see one example, one quick example, so that we can appreciate the working of a blocking and a non-blocking assignment at least, and then we'll go what's the special about sequential circuits, what's the rule, when we should use a blocking statement, when we should a non-blocking assignment, right? And for sure we are clear that why we need to use a assign statement. Anytime we are doing a continuous assignment using a where, we need to use a assign outside procedural block. But these two type of assignment will be done inside a always block, inside a procedural block. Okay, let us quickly see one example. If I have three variable L, A equal to 10, B equal to 20, and C equal to 15, right? I have initialized them. Where I initialize them inside an initial block. So an initial is a procedural block. So your A, B, C will become a variable type or a range type. So before that, I need to declare what's my A, B, C are. If I write assign here, then this I can't write them inside initial block because it's a procedural block. It's a wrong. So I need to cut my assign statement, and my this everything will become where. I am just repeating the same thing just to embed those theory inside you. Okay, let not deviate from our things. What we are doing. Okay, and then I'm writing a. I'm assigning a, and I'm giving some delay. So this is how you provide a delay. Now, is it a 5-second delay? It could be a 5-second delay, but I need to assign the unit of my delay. So that's not the scope of today's lecture. So just for now, you just assume it's a 5-unit delay. So what I'm doing after 5 unit of delay, okay, why should we introduce something new here? Let us not introduce any delay for today at least. I'll take it in later. Okay, there is no delay. So I'm writing B plus C. Okay, and in the next line, I'm again writing A plus 5, and in my third I am again writing C equal to A minus B. You are sure, right? This is equal to, because this is the assignment only, but it's a non-blocking assignment. Now what would be my answer? You have 20 seconds. Tell me what would be my answer. If you can tell me the answer, wonderful. You actually know how non-blocking and blocking assignments are working, because this is an example of non-blocking assignment. Okay, let me explain what the answer would be. So for the first one, your answer would be B plus C. Very easy. B plus C, it would be 35. For the second, it would be A plus 5. Now you will say, hey, you are wrong, but I'll tell you I am not wrong. For you, it would be, hey, in first line my A got 35 and I am adding a 5, so it need to be 40. But no, brother, it or sister, it's not a 40. It would have been 40 if it's a blocking assignment. We were using a blocking assignment, because that this second line will only get executed whenever my first line execution is done. But as it's a non-blocking assignment, so the magic is that all the three lines gonna execute at the same time. If we provide some, if we had provided some delay here, for example, for first line and second line I haven't given any delay, but for the third line I am giving some delay of 5 units, then probably your first and third will get executed at 0 time, and your B would get executed after a delay of 5. But since we haven't provided any delay, so this 3 line will get executed at the same time. So that means your A will get the initial value only, and which was 10. So we will get 15 here, and the same thing is for third line also. A initial value, B initial value, so A was 10, B was 20, 10 minus 20, it is minus 10. And this is a huge example. Probably in your interview, front-end interview, you will get something like that. In your interview only, you need to explain why things are happening, and you need to tell them, right? So this is a nice example to let you know how non-blocking assignments are working. Now, what's the rule? How we should go? In HDL beats, they have done a wonderful things. Actually, they have just given you a golden rule, the golden rule of thumbs, and they are saying it here. See, they are saying that in combination always block. So what does a combination always block means? Any block which have a excitation of star at the rate in the sensitivity, sorry, in the sensitivity list they have a underscore star. So anytime you are using that type of always block, use blocking assignment. And anytime you are using a clocked always block, post clock, like post age, next age, that time use a non-blocking assignment. But that's a golden rule of thumbs, but that is not always correct. You can always do interchangeably, but the problem is that you might get some huge error which is extremely hard to find. So that's why as a beginner they are giving us a golden rule. Just follow it, and for sure you won't be having any issue in your simulations. In your logic development, like any logic you are thinking, your Verilog should emulate the same thing, so there won't be any discrepancy. And from here we also deduce one thing, and that is anytime you are doing codes for combinational circuit, then use the blocking statement, and anytime you are doing codes for sequential circuit, use non-blocking for sure. And mostly, as a rule of thumb, sequential logic are written inside a clocked always block, and the reverse is true for the combinational circuits. Now the question is, what's the difference between a sequential circuit and a combinational circuit, so that we are having this much of discussions. So for that I need to write something here. So for example, take this example. Here you have one AND gate. Okay, let us take two AND gate, and both of these two going somewhere, and then we have a OR gate, and we are getting our out here. And here we have A, B, C, and D. This is a combinational circuit. Now tell me how things will work. We can give clock here also, clock control, but I am making things simpler. For now, just assume there is no clock controls are there. So now anytime you give A and B, right, A and there would be some delay in our gate. So after some delay, we'll get a result here. We'll get a result here. And then after some other delay, we'll get a final result here, right? X or Y. Those delay would be very, very minute compared to your clock periods. So without losing any generality, we can directly say that, hey, actually we are getting our output instantaneously. Anytime I give A, B, C, D, I'll get XY here. This will calculate and I'll get a XOR Y, right? I am not holding on any data in between. Here also I am not holding, or if there are some other stages, stage 1, stage 2, stage 3, in any stages, I am not holding any data. One thing is that this is a combinational circuit, I don't need to, and the another thing is that combinational circuit have no ability to store the data, right? And that's why I'm not storing any data. But at the same time, for example, if you consider a shift register, and we have already done one shift register code, right? So shift register are achieved through D flip-flop. So for example, here you have 3 D flip-flop. Here is your input A, and then your first output x1, x2, and then the final output, and all of them have their clock, right? And clock are here. Now just tell me one thing. Initially, for example, initially we started with a 0, 0 and 0. Anytime we got a clock, this D flip-flop could be a positive edge trigger or negative edge trigger. So for example, it's a positive edge trigger. So anytime I got the positive edge of my clock, and in the input probably I have given a 1, right? So anytime I got a positive edge of the clock, what will happen to your this? You will get a 1 here, right? And previously 0 was there, so this 0 will get transferred to here, so it will be 0. And previously here 0 was there, so it will again transfer to here, 0, 0. And the positive edge is done. So now I need to hold this value, this 1, this 0, this 0, till the time I get the next clock. Anytime I get the next clock edge, I will again give something here. For example, I have given again 1, and things will follow. One thing you need to observe here, how many things are happening here in one clock or in one instance of time. You are, or your circuit is doing three parallel job here. 1 transfer, 2 transfer, 3 transfer. Now for emulating this thing, if we use a blocking statement, then what will happen? You need to wait to finish this transfer first, and then only you will do this transfer. But probably at the same moment, things which were there in my previous clock already got changed because I did this transfer first. So that's why anytime you need to simulate the logic behind a shift register, you need to use a non-blocking assignment. And this just an example of one simple sequential circuit. In all the sequential circuit, we are doing the same kind of thing. We are holding the data, and anytime clock is arriving, we need to do many tasks concurrently, right? So that's why it's very important that we should use, anytime we design any sequential circuit, for sure we need to use the non-blocking statement. Now let me give you another example. Okay, so for example, I am not defining everything else. We need to swap two value, a and b. Value of a and b we need to swap. A have 10 and b have probably 15. So we want to swap them without defining a third variable or a temporary variable. So what I did a equal to b and I did b equal to a. Now tell me, with this, what the result I will get for a and b? For a, for sure I will get a 15, and for b, because a is 15, so b will be again 15, but our b needed to be at 10. And what I am doing, I am trying to achieve it through a blocking statement, right? But blocking statement is not applicable here. If I use, then I will lose this type of logic. Probably this type of logic we need to implement in our digital circuits, and in Verilog I am trying this, so we are losing out on the logic. But at the same time, if I do this, not here, if I do this, a equal to b and b equal to a, then what is happening? Tell me, will you get the answer? So as it is a non-blocking assignment, there is no delay specified, so this fellow and this fellow will get triggered same time, in the same time. So the value in the v will get in the a, and value in the a in the initial, not after changing. This b is changing your value of a, but before changing only this line got executed, right? Both are executing at the same time. So that means our b will get the old value of a. So here v will get 10 and a will get 15. So that's the beauty of your non-blocking assignment, and that's the thing we need to achieve in our circuit, because in our sequential circuits, that's the scenario we will have for sure in any sequential circuit. Now there is a very much important thing we need to observe, and that is I said we have two always block. This is my first always block and this is my second always block. And yes, inside a procedure block, inside a module you can have infinite number of procedures block, right? So we can have this. So here you have written a equal to, let me introduce delay also, after a delay of 5 b, and in your second always block or in the procedure block you have written c equal to after a delay d, after a delay of 5 d. Now tell me, uh, and this is coming fast. In your code you have written this is in top, this one, and then this one down. Or for your more clarity, let me write it in down only. Okay, after you have finished like defining this always block, you have written your second always block here. So in combination, in general coding scenario, will for sure will say, hey, this fellow will get executed first and then this fellow. But dear, it's a Verilog world. So in Verilog world, what is happening? Any always block you define, all the always block or all the procedural block will start executing at the same time, right? There would be minor differences in your simulator, but there we are not going now. And here we have told our always block that after 5 seconds you start this one, and here also not 5 second, unit of 5 delay, and here also unit of 5. So that means both the assignment will take place in the mostly in the same time. So therefore blocking statement will block the next statement only inside that procedure, only inside that always block. For example, inside this always block, if I had another line here, anything, then that line got blocked by this fellow, but not this line, because this is in another always block. So that is also a very important thing to know about blocking statements. There are many theory are there, but for now we don't need those. If required, I will explain in some other video. But for now, lots of theory, let's do some practice. Okay, one thing very important here, these two you already know, right? Yeah, in last video we have used. But if you use this one, like your always block which are clocked, so sometimes what happen, our output are ready, but we are just storing them, we are waiting for the next clock to arrive, because we will execute the always block only in like clock signals. So that's why in the output, for sure always a register or a flip-flop going to be synthesized, right? So that you need to keep in mind. Not so important for now, but in future it's important. Just I'm giving a hands up. Okay, let's do the practice. So in our practice, what we need to do, let me go here, we need to build a XOR gate 3-way. So we have 3-way, we know, 3 assignment statement we know, so we need to use those. So let us try it out. So first, which one? Let's try with assign statement, which we know for sure, and I'll write assign. Now tell me which one we should use with assign. Where only, right? If I use res, I'll get some issue, so I'll use this one. And we know what's our XOR. It is the bitwise XOR, because 1 bit only, so this is XOR. Now we need to use a combination always block, so we'll write always and then sensitivity list at the rate star, because combinational for sure is the rule of the thumb, use a star and go inside, and then write assign. We can't write, we'll directly do like directly use the blocking statement here. Inside a combination always block, rule of the thumb, use a blocking statement. So for blocking statement, we can use this or this, both are okay, but for now let us see. And don't forget the semicolon. This is one always block and then another always block, but now we will use sensitivity list as at the rate pos, right? Pos age of the clock, and pos age of whom? Pos age of this clock variable, so clock. And what should I do? I should assign this fellow. We are done. So here what will happen, this is concurrently driven, this is also mostly concurrently driven, but we have a register defined here and we have wire defined here. Here this is a register, but here your output will come maybe after some delay, so we need to have a storing ability. So here we are not synthesizing XOR only, we are synthesizing XOR, and then XOR, then your output of okay, XOR gate only, just assume output of XOR gate will go inside a flip-flop. It will be controlled by a clock and then the output, right? And here your A and B. But for other two instances, this and this fellow will just build a XOR gate here. And we got a success, but it's very important to see this simulation to understand what is happening actually. These are your input clock AB. These are mine, right? Your assign statement. So just observe here, so beautiful things are there. This is from your assign statement where we are getting things instantaneously. This is also from the like same only concurrently driven, but using a always block. In last class only we said your star always block and the assign statement both are same, just we use the always block just to get the rich statements like case, if else, those things. But here those things we are not using, so that means both are same. And see, your answer also both are same, but for this fellow we are getting the answer after a delay. Now the question is that why we are getting it after a delay. See, in this positive age, right? In this positive age, how I am knowing positive age? But just go up and see, this is my positive age. So in this positive age, I am giving a from many time seconds ago, but I have changed my b here. So anytime you change your b here, instantaneously there are a delay, very minute delay, we are getting a result here because both are combinational circuits. But the beauty of a sequential circuit is that, let me just delete that, after you got your input here in this positive clock, you will do the execution. So here I got my input and I started my execution, and for sure I got my result also, but I won't give it to my outside world. What I'll do, I'll store it and I'll give it only in my next clock age. There is a doubt, small doubt. You might say, hey, when you have your XOR result is ready, then why not give it to the outside world? Why we are again creating a what called flip-flop here? Why we are waiting for the next positive clock? The answer is that the outside world, right? Outside world, where anytime your first positive age arrived, that time your outside world may be doing something else. What you are doing the XOR calculation, they are maybe doing something else, they are busy doing that. And if you give a output in between, they are doing something else, then probably we'll get a wrong result, right? They are doing something else, but you are changing their input signal in between the clock. There are many concepts like setup time, hold time, and we are violating those for sure. So that's why what we do, we make our output ready, store it, let outside world do their work in that clock pulse, so they would be ready, and after they're ready, then only in next clock age I'll give my final output to them. So that's why, and that's why the name. So that's all for today. I haven't prepared any question for today, but yeah, try to give answer for yesterday's question. So here I have said we have three error, right? So first issue is that you see you are initializing your clock every time always is coming, which is not perfect. So here you must need to define a initial block, because define between a always block and initial block is that initial block will only run for once, and anything initializing need to be done only once. So this fellow need to go inside initial block. That's a one error. And the second error is that we are nowhere we are defining when to stop. It's a code, right? It's not a hardware that we can power off it. So to power off our code, we need to define a like we have some keyword like finish. So we need to give finish after some delay. So we need to define another initial block, and again we can have many initial block, and we can write after a delay of probably 1000 time unit, you finish the execution. So that time your block or clock generation will finish. I said three error, I got two error. What's the other error? Okay, I'm not sure. See if you find anything. Okay, so we'll meet in our day number 14. Till then, keep smiling and tata bye bye. And please like the video.